Today we are going to be looking at sections 3.2 and 7.2. So we are going to continue looking at proving triangles congruent using four postulates. Today what we're going to do though is instead of looking at a picture and just determining based off the markings how they are congruent, now we're going to start getting into geometric proofs. So essentially we're going to be looking at a two-column proof where the left side are going to be all of our statements and the right side is going to be all of our reasons. Now, when you're doing two-column proofs, there are several things that I'm going to need you to do. One thing I'm going to need you to do is I'm going to need you to always number your steps. Okay, so anytime I am going to put something down for a statement, I number it, and then my reasons that's going to justify it also needs to have that same step number. The other thing is that you're going to want to sketch a picture because part of doing a proof is marking up your picture to help you justify along the way that you are reaching what you are trying to prove. So let me show you what I mean. So go ahead and sketch this picture. And here are my given informations. We are told, so statement one, we are told that the segment QR is congruent to the segment SR. That's my statement. My reason for that statement was that it was given to us. So that's something that's nice for reasons. If something is given, our reason is just that it was given. But now I'm going to mark that information in my picture. So anytime a statement is talking about congruent, we need to mark that in our picture. So we've got QR. I'm going to give it one tick mark. So that means that SR is going to get one tick mark. All right. I can't really expand on that any further. So that means I'm moving on to my next statement, which is going to be my next given. So I am told that the segment QT is congruent to the segment ST. Once again, numbering my reason, it's just given to us. So now I'm going to mark that in my picture because I'm talking about congruent. So I got to mark it different. I'm going to give it two tick marks. So there's the segment QT, has to have the same tick marks as the segment ST. That's all that's given to me. In order to prove that I have congruent triangles, remember we talked about we need three things. And so remember the methods. We've got side, 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 angle, side, angle, side, angle, or angle, angle, side. So in this problem, notice that we are given two sets of segments. Well, angle, angle, side only deals with one set. So that means that that is not going to be a way to prove these triangles congruent. Same thing with angle, side, angle. There's only one set of segments in that particular method, and we have two segments. So that one isn't going to help us. So we're either looking to try to prove these triangles congruent by side, 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 or side, angle, side. Notice that I can't assume anything about angles or segments. However, my third step, hopefully we notice that these two triangles share a side. They share the side of RT. And so remember, we can say that the segment RT is congruent to itself. Now notice that what I'm trying to prove, I've got RT as the middle and the last, and notice that RT is the middle and the last. So I get to leave the letters exactly how they are. So I can say that the segment RT is congruent to the segment RT. My reason for this, well, how come something is congruent to itself? It's congruent to itself by the reflexive property. Okay, and then notice that I did mark up my picture. So because I have three different sets of congruent segments, we do have enough to say that my fourth and final step is what we are trying to prove. We are able to say that the triangle of QRT is congruent to the triangle of SRT. And because we are only talking about segments here, it would be because of side, side, side. Now, when we are doing these proofs, not only are we going to say side, 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 but now in parentheses, we're going to justify that we did this correctly by going back up through our proof and double checking. So the first S stands for segments. I'm looking for the first set of congruent segments that were within my triangles. That happened to be step number 1 when I said that QR and ST, those segments were congruent because they're 2 segments in my triangle. Where then my middle letter is another S, so I'm looking for another step where I have congruent segments. Well, that happens to be step number 2. Notice that that is where QT and ST are segments within my triangles. The last letter we have is another S, so where's my third set of congruent segments? That came from step number 3. So that one was pretty easy to double check because it was just 1, 2, 3, bam, there's my answer. Okay, it's not always going to be that way, but for this one, it happened to work out nicely for us. All right, so we're going to look at another proof. Once again, on the left are going to be all of our statements. And on the right are going to be all of our reasons. I would suggest that you pause the video, sketch the picture, maybe even write down the given and what we're trying to prove. Okay, so hopefully you did that. I'm going to go ahead and I'm going to start by numbering my statement. I'm going to write down that very first given, that angle B is congruent to angle C. So over here for my reason, I number my step, and my reason is that it was given. And so because we're talking about congruent angles, I'm going to mark it in my picture. So angle B and angle C get the same marking. Second step, I'm going to go to my second given. I'm told that the angle BAD is congruent to the angle of CAD. My reason for this, it is also given. All right, so I got to mark that. So if I follow the letters, notice that the A's are in the middle. So BAD, I have to mark this a little bit different than the angle B and angle C. Follow CAD, that's this one over here. So those 2 angles are congruent. I don't have anything else that's given to us. So now it's a matter of trying to figure out how am I going to try to get to prove congruent triangles? Well, remember, we have to have 3 things congruent in order to make that happen. So once again, here are the 4 methods, in which to prove that we have congruent triangles. Well, hopefully we're noticing that side, side, side is not going to work because our first 2 givens talk about angles. Same thing with the side, angle, side. There's only 1 angle in that method, but here I have 2 angles that are a part of my triangle. So it's between side, angle, side, or angle, angle, side, which means we're looking for a segment that we're going to be able to mark as congruent. So what do we notice again about this picture? Well, just like the last picture, these 2 triangles share a side. They share the side of AD. So my third step, I can say that the segment AD is congruent to itself. So if I look at the letters of how I'm trying to prove the triangles, notice how it go from A, which is first, to D, which is last. Over here, A is first and D is last. So I get to keep the letters in the same order. So once again, what's my reason for stating that the segment is congruent to itself? Well, hopefully we're once again okay with it, is the reflexive property. So I marked my picture. So now I do have 3 things marked in my triangles. I just have to determine, in order for me to say that these triangles are congruent, so triangle ABD congruent to the triangle of ACD, we just have to know, is the side included between those 2 angles or is it not? Hopefully we notice that the segment AD is not in between the 2 angles that are marked. So angle, side, angle is not going to work for us, which tells us that this is because of angle, angle, side. And then once again, I want to put my numbers going back through my proof and justifying where those congruent pieces in my proof were written down. So since A is first, that's representing congruent angles. Well, in the very first step, we have our angle B and angle C. They're inside the triangle. That was one of the angles that helped me get congruent triangles. My next letter is another A. So I'm looking for another set of angles. Well, that happens to be step number 2, where we have another set of angles inside those triangles. The last letter was S, so we're looking for congruent segments. Well, step number 3 got us our congruent segments. Since I was trying to prove congruent triangles, we're done. All right, so I'm going to go ahead and pause the video, sketch the picture, write down the given and what we're trying to prove, and then we'll go through it. Okay, so hopefully you did that. Remember, we want our statements on one side, the reasons on the other. So my first step, I'm going to write down that first given. O is the midpoint of the segment MQ. Why do I know that? Well, that was given. Notice that what was given doesn't have the symbol of congruent. So that statement is not going to allow me to mark up my picture. However, it has a vocab word which we can expand on. So that's why we were really focusing on drawing conclusions, because midpoint is a vocab word that we can expand. My second step is not going to be my next given. Instead, we're going to talk about, okay, well, if the segment MQ has a midpoint, what do we know? So I'm going to highlight the segment of MQ. If O is the midpoint, hopefully we're okay with knowing that a midpoint is going to divide a segment into 2 equal pieces. If we look at it, it's the segment MO, which is going to have to be congruent. So now if I look at my letters, M and O are the first 2 letters. Q and O are the first 2 letters. I got to put the Q and the M together. All right. So why am I going to be able to say that those 2 segments are congruent? Well, this is where our if-then sentences are going to come into play. What we knew was step number 1. That was our given information. Remember, the if part of our sentence is the given information. So I would say if a point, and I'm going to abbreviate point like this, is a midpoint, and I'm going to abbreviate midpoint like this. So if a point is a midpoint, then, and so now we can talk about what we're concluding. Well, we're in the second step. We're concluding that we have congruent segments. So then it divides a segment into 2 congruent segments. Okay, so I am abbreviating a bunch here, but the abbreviation is still getting me to my point. If a point is a midpoint, then it divides a segment into 2 congruent segments. And then I get to mark those segments in my picture. Okay, so we're not going to be able to expand on that second step. Okay, so that means that our third step, we can go back to our next given. We are told that angle M is congruent to angle Q. Our reason? It's given. And so then I'm going to mark that in my picture. So angle M gets the same marking as angle Q. I've run out of givens. The third step here isn't going to allow me to expand like the first step did. So because I don't have 3 things marked in my picture, I'm not going to be able to go to what I'm trying to prove yet. So we need one more thing. So remember, our 4 ways are side, 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 angle, or angle, angle, side. Hopefully we're okay with noticing that it's not going to be side, side, side. Okay, right now we have 1 angle and 1 side. So any of those other 3 could potentially be our answer. So now we have to look at the problem or the picture, and we have to kind of decide, because there's no other givens and we can't expand on anything, what can we maybe get out of the picture? Well, hopefully you notice that there are several angle O's. Notice how these angles right here are vertical angles, and vertical angles are congruent. So step number 4, I have to use 3 letters, but I'm going to say that the angle MON is congruent to the angle. Now, if I started with M, I have to start with Q because those 2 angles are congruent. Then O is the vertex, so that goes in the middle, and then P goes next. So like we said, those two angles share a vertex. They're directly across from each other. So we would say vertical angles are congruent. Now we can look at our picture and we can see that there are three things that are marked. So my fifth step then is going to allow us to prove what we're looking for. We can prove that the triangle MON is congruent to the triangle of QOP. So now we have to look at the markings. Well, because we came up with another angle, it's not going to be side angle side. Because the side that I have is in between two angles, that is going to be this conclusion of angle side angle. But now I want to go back through my proof and I'm looking for the steps that got me these congruent pieces. So since angle is first, I got to look through my proof and find where's my first set of congruent angles that are in my triangle. Well, that actually didn't happen till step number 3. Step number 3 got us our first angles that we marked in our picture. Then I look at the second letter. It's an S. So that means I'm looking for a segment. So where did we have congruent segments? Well, that came from step number 2 when we were able to expand on what the midpoint was. The last letter is an A, so we're looking for congruent angles. Well, notice that came from step number 4 when we said our vertical angles were congruent. And this would be our proof. All right, so we have a theorem. Remember, theorems are mathematical statements that can be proved. Hopefully this statement just makes enough sense where I don't have to truly prove it. But my theorem is if two angles are right angles, then they are congruent. And hopefully that just makes sense. If you have right angles, those are 90 degrees. If two angles have the same measure, they're congruent. Hence, if two angles are right angles, then they are congruent. All right, let's look at this. So once again, I would suggest that you pause the video, sketch the picture, write down the given and what we're trying to prove. All right, so we've got our statements, we've got our reasons. I'm going to go ahead and I'm going to write down my first given. And actually, if you notice that the first two givens, they share the same symbol. So I'm actually going to put these two together. I'm going to say that the segment GF is perpendicular to the segment FH and that the segment KL is perpendicular to the segment of LJ. I normally don't group things together, but in this case, because they're both perpendicular and they have a specific thing that we're going to have to expand on, that's why I put them together. Okay, remember that's given information. Okay, so perpendicular is a vocabulary word. Okay, right now, I'm not going to be able to mark anything in my picture until I know what it means to be perpendicular. So remember, perpendicular, in this case, are two segments that form a right angle. So if we look at the first set of perpendicular segments, notice that GF, FH, it looks like they're intersecting at F. If I look at my picture, there is only one angle F, so I can use one letter. So I would say angle F. And if I look at the next set of perpendicular, we've got segment KL and LJ being perpendicular. So notice that they seem to intersect at L because that's what they share in common. Well, L is the only angle that I have there, so I can use one letter. So I would say that angle F and angle L are right angles. And so now we're going to have to write an if-then sentence justifying it. So remember, the if part was what was given. Well, step number 1 told us that we had perpendicular segments. So remember, if two segments are perpendicular, then they form right angles. So notice that because I was concluding right angles in my statement for step 2, my reason for step number 2 has to say right angles. And so I'm going to mark that in my picture. Angle F is a right angle. Angle L is a right angle. All right, now this is where that theorem that I just talked about comes into play. The moment I see that I have at least two right angles in my picture, or in this case, step number 2 told me that I have two right angles, we are going to expand on that even further. We are going to be able to say that angle F is congruent to angle L. And it's because of that theorem that we just mentioned. If two angles are right angles, then they are congruent. Okay, and remember, we have to have congruent pieces in order to then get us our conclusion of proving that triangles are congruent. So that statement is very important. So the moment you're ever given perpendicular, you will always expand with 2 extra steps. You'll say that you have right angles, and then you'll say that those right angles are congruent. All right. That's all I can do to expand on those first 2 givens. So now I'm going to move on to the third given. I'm going to say that the segment GF is congruent to the segment KL. Once again, my reason, it's given to me. And now I'm going to find it and mark it in my picture. GF, I'm giving 1 tick mark. So KL gets 1 tick mark. I get to then move on to my last given, that the segment of FH is congruent to the segment of LJ. Once again, that was given information. I'm going to mark it in my picture. FH, I'm giving 2 tick marks. LJ gets 2 tick marks. Notice that what we're trying to prove is congruent triangles. You have to have 3 congruent pieces in order to do so. That is by side, 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 angle, side, angle, or angle, angle, side. If we look at how our pictures are marked, hopefully we notice we've got side, angle, side here. So my 6th and final step is what we're trying to prove, that the triangle GFH is congruent to the triangle KLJ. This is because of side, angle, side. And now I have to go back through my proof and find my congruent pieces for the triangles that we marked up. So since S is first and that's side, we want a step that has congruent segments that are within my triangle. Well, that happens to be step number 4. The middle letter is an A. So I'm looking for, where did I state that I had congruent angles for my triangle? Well, that came in step number 3 when we said that we had congruent right angles. The last letter is another S, so I'm looking for another set of congruent segments. Well, that came from step number 5. That was one of our givens. So then that concludes our proof. Okay, so this is us doing 2-column proofs to prove that triangles are congruent using these 4 postulates.